Alright, welcome to our regular math tutorial. In our past lecture, we talked about various kinds of logarithmic equations. Today, we are going to look at deriving the formula for the circumference of a cycle. You probably know this, but perhaps you don't know how the equations came about. Now, to derive this formula, we begin with the unit cycle. A unit cycle is a cycle whose center is at the origin and whose radius is r. So you have a cycle like this. This is a cycle, so I'm going to draw a Cartesian plane and then sketch a cycle right here. So this is a unit cycle. This is y, this is x, this is negative x, and this is negative y. So the origin of this cycle is 0. And the distance from here is some r, the distance from here is some r. Now we are going to use the calculus approach to derive the formula for the circumference of a cycle. First, let's give you the equation for a cycle of this form. So a cycle whose radius is r and whose center is at the origin is a unit cycle, and the formula is s squared plus y squared is equal to r squared. So this is the equation of this cycle. From this equation, we can find something called the slope of this equation, or we call it the derivative of this equation with respect to x. So we differentiate this, we have 2x plus differentiate, we have 2y dy by dx is equal to differentiate r. Remember, r is a number, so the derivative of r squared is just 0. We are about to solve for dy here. So solve for dy, we have 2y dy by dx is equal to minus 2x. Divide both sides by 2, we have y dy by dx is equal to negative x. And if we divide both sides by y, we have dy by dx equals to minus x over y. So the derivative of this cycle is a cycle that has radius r and whose center is at the origin is minus x over y. Now, the distance from here, and this arc length from here all the way here, this is called the arc length of this particular curve. So to find the arc length of a curve, we have an equation we use. The arc length is denoted as s, and s is equal to the integral from a to b of the square root of 1 plus parenthesis between dy by dx equals all squared. This is the formula for finding the arc length of any curve. So you have the bound of the curve from some a to some b, and you have the derivative of the equation of that particular curve, and you use this to find the arc length. Now we are going to use this to find the circumference of a cycle, because the circumference of a cycle is the entire distance around the cycle. So we are going to use one arc length, and then using one arc length, we are going to find the total arc length of this cycle. Now, we already have our dy by dx, which is this. How do we find our a and our b, which is the bound? Since we are looking at this arc length, we are going to say that our a is 0, meaning we are moving from 0 to some point r, which we obviously don't know. So we have represented that as r. So we have to find the arc length of this cycle, of this particular curve, from here to here. We have s is equal to the integral. Our a now is 0, because we're coming from 0 to some point r of the square root of 1 plus. So our dy by dx is already negative x over y all squared. So s is equal to the integral from 0 to r of the square root of this 1 plus s squared over y squared. The square is called, that's what you have. So you have the arc length. The arc length is equal to the integral from 0 to r of the square root of. If I add this fraction, I'll have this plus this, will give me y squared plus s squared over y squared. That's exactly what I have. Now I can rewrite this as s is equal to the integral from 0 to r of the square root of. Instead of y squared plus s squared, I'm going to write s squared plus y squared all divided by y squared. Now, what is s squared plus y squared according to our equation? S squared plus y squared is just r squared. So we replace our entire s squared plus y squared with r squared. So I have s is equal to the integral from 0 to r of the square root of r squared over y squared. Now, I'm differentiating the entire sum with respect to x. So you have dx, this integral is with respect to x, have dx, 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 and dx, dx. So I have s is equal to the integral from 0 to r. If I simplify r squared over y squared, under the square root I have r over y dx. So what is my y? From this equation, s squared plus y squared is equal to r squared. So since s squared plus y squared is equal to r squared, I can solve for y. Y will be equal to the square root of r squared minus s squared. This will be my y. I replace it for y under here. I'll have s is equal to this integral from 0 to r of r over y. What is y? Y is the square root of r squared minus s squared dx. That's what I have. Now, we know from our integration classes that you have an integral of this form, you use something called trigonometric substitution. So anytime we have the root of r squared minus s squared, we use the substitution, let x equal to r sine of theta. That's what we do. So that's exactly what we're going to use here. We say let x equal this x, it should be r sine of theta. Since we have dx, we have to replace the value of dx in terms of theta. So we have dx is equal to r cos theta d theta. Now, the bound cannot remain the same. The bound is from 0 to r, and it cannot remain the same. So what we are going to do is we are going to change the bound at the time x was 0. From here, we have 0 is equal to r sine of theta. We have to solve for theta, so it means sine theta is equal to 0. Divide by r, divide by r, sine theta is equal to 0. It means theta will be equal to sine inverse of 0. And sine inverse of 0 is just 0. So at the time x was 0 from this lower bound, theta will be 0. And at the time x will be r for the upper bound. What we have? We just have r is equal to r sine theta. So if I multiply r, we have sine theta is equal to 1 because r divided r is just 1. And theta will be equal to sine inverse of 1. And sine inverse of 1 is pi by 2 or 90 degrees. So we have converted from x now to r. So we have s now is equal to the integral from 0 to r. And our r now from x equal r, our theta is pi by 2. Pi by 2 of r, this is just a number, dx. Our dx is r cos theta d theta, all divided by the square root of, it should be r squared minus our x. So we say let x equal to r sine theta. So it's r sine theta and all squared. Now, what do we have from there? We have the integral. So s is equal to the integral r times r is just r squared cos theta d theta, all divided by. This now will be, the bound is from 0 to pi by 2. Don't forget the square root of r squared minus r squared sine squared theta. So r sine theta all squared is r squared sine squared theta. So we have s is equal to the integral from 0 to pi by 2 of r squared cos theta d theta, all divided by the square root of. If I factor out r squared, I'll have r squared by 0 1 minus sine squared theta, so this. I have s to be equal to the integral from 0 to pi by 2 of r squared cos theta d theta, all divided by. This r squared leaves for under the square root, that's r, so I have r. And 1 minus sine squared theta is cos squared theta. And if cos theta comes out of the same square root, it becomes cos theta. So cos theta and cos theta cancel. R going to r squared, it goes r times. So s is equal to the integral from 0 to pi by 2 of r d theta. Now, when I reach here, I can integrate r d theta because r is a number. Since r is a number, I have S will be equal to r theta. Because equal to theta, just theta from 0 to pi by 2. That's what I have. So just keep that in mind. Keep that in mind. So we have S is equal to r theta from 0 to pi by 2. So S will just be equal to r. R is a number. Theta starts from 0, so it's the upper bound minus the lower bound. Upper bound is pi by 2 minus the lower bound is 0. So the level of the arc S will just be equal to r multiplied by pi by 2. Now S equals r pi by 2. So S will just be equal to r pi over 2. Now let's see something right. S equals r pi over 2. It's just the length from here, here. It's just one of this arc, this curve. What the circumference is from here, 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 and here. So it means the circumference is 4 times the length of the arc, S. So the circumference is 4 times the length of an arc, S. So the circumference is equal to 4S. Well, it's 4 of those stuff. So the circumference will be equal to 4 multiplied by, and our S is r pi by 2. So S will be equal to 2 goes into 4, it goes 2 times. So it's 2 r pi. If you want to change it, you have the circumference will be equal to 2 pi r. And that's how we derived the formula for the circumference of a cycle. In our next tutorial, we are going to look at the formula for the area of a cycle, deriving that from calculus perspective. Thank you very much for listening and see you later.